Now, the set definition of addition allows me to construct a different algorithm for addition, and this is going to be derived as follows. So let's go ahead and try an addition using a place value chart, and we'll use a concrete representation of our objects, and let's add together 2, 3, 4 base 5 with 3, 4, 2 base 5. Now, in this problem, I want to use a place value chart with concrete representations. What do I mean by that? Well, we'll set down an empty place value chart for base 5, where each unit is 5 of the preceding unit. And we know that we're dealing in base 5 because our numbers are in base 5. So there's our place value chart, a place, a place, a place, a place. And I've written down 4 places here. I could have more. I've written down what each of the units look like, although I don't really need to. Again, here's my 1. 5 of these form the next unit. 5 of these form the next unit. 5 of these form the next unit. And were I artistically inclined, 5 of these would form the next unit, and so on. Again, I don't actually need to draw what the units look like. They're just there because I happen to have some free time and would like to draw. So let's see. I'll go ahead and set down my numbers. My numbers are 2, 3, 4 base 5 and 3, 4, 2 base 5. So I'll set those down. And I want a concrete representation. These are abstract symbols that tell me how many of each of these that I have. So let's go ahead and write down a concrete representation. And I'll do that by replacing our abstract number symbols with concrete representations of what they are. So here I have 4 of these things. So rather than writing 4, I'll write down a bunch, 4 of these little squares. I have 3 of these, and I have 2 of these. Likewise, I have 2 of these, 4 of these, 3 of these, and there's my concrete representation of the sum 2, 3, 4 base 5 plus 3, 4, 2 base 5, and, well, now I can use the set definition. I have 2 sets. I'm going to put them together into a single set, and that's my sum. And so I have a set of these, I have another set of these, I run them all together, and there's my sum, 2, 3, 4 base 5 plus 3, 4, 2 base 5. Well, I'm not quite done yet. I actually want to find what that sum is, so I'll go ahead and do the bundling and trading. So remember, I'm working in base 5, which means that anytime I get 5 of something, I will be able to bundle it and trade it into the next column. Now, here's a rule for cleaning. Work in one direction. And in this particular case, I want to work from smallest to least, because what's going to happen, I'm going to bundle some stuff and maybe move stuff into here. I'm going to bundle some stuff, maybe move it over. Bundle and move over. If I work from right to left, I never have to go backwards. The problem is if I bundle here and move over, I might bundle here and drop some things into here that may cause me to have to re-sweep. So let's sweep in one direction, working from the smallest place. I'll take a look at this, and look, I have a bundle of 5 here that I can put together. And, well, that doesn't belong here anymore. It really belongs over here, so I'll slide it over. And again, I have a bundle of 5 here. And again, this doesn't really belong here. It belongs to the next place over. And again, I have a bundle of 5 here. And again, this doesn't really belong here. It belongs to the next place over. And I have no more bundles I can make, so now I'm ready to write my final answer. And again, what I'm going to do, returning to my abstract symbols, I'm just going to record how many of each of these that I have. So I have 1, 1, 3, and 1, and so my final answer is 1131, and reminder, we're working in base 5. I'll write that down at the bottom.